Hi, in this video, we're going to look at factoring by using the GCF. So we're going to solve quadratic equations and we're going to factor using the greatest common factor for those of you that have forgotten what the GCF means. Okay, so usually when I can use the GCF method, I'm given a quadratic equation in the form ax squared plus bx. So notice that the c is missing. So if I were to write out my coefficients for number one, for instance, I have a, in this case, is equal to 1, b is equal to 10, and c is missing, so it's not there, which means that there is no c term, and so therefore we can say that c is equal to 0. So whenever I see something like this where c is 0, if I look at the first two terms, or the terms with the coefficients a and b, I can see that they both have a common factor. And I can see that both of those terms have an x value in them. So I can factor out x as my greatest common factor. So if I were to do that in example 1, what I find is that I have x outside, and when I factor out an x, I'm left with an x inside the brackets, and then I'm going to add 10, and only 10 because I've already factored out the x from the 10x. And in this case, I can set this equal to 0. Okay, so what the rule tells me is that if the coefficient c is equal to 0, then both the second and the next term both have a factor of x, which can be factored out. Sometimes more than an x can be factored out, but at least you know that at least one x can be factored out. And so that's how we factor using the greatest common factor. It's very simple, okay? So now what I'm going to do is I'm going to set each term equal to 0. So x is equal to 0, and x plus 10 is also equal to 0. So therefore, I know that one of my x values is 0, and the other would end up being x equals negative 10. Okay, so in this case, x is equal to 0 and x is equal to negative 10. And if I wanted to put those back in and check them, which I should always do, then of course I would get the same thing on both sides. Okay, so we can see that the greatest common factor method is probably the most simplified method of all. So now let's look at example 2. In this example, I have 3x squared minus 18x is equal to 0. Well, let's look. I have an x in both of those. Okay, so when I put my brackets there, I'm going to factor out an x, at least I know. Well, it looks like I can factor out something else. If I look at the two coefficients, if I look at a and b, a is 3 and b is 18. And so 3 and 18 do have a common factor. Of course, they have a common factor of 3. So I can factor out a 3, and when I factor out 3x in the brackets, that's going to leave me with just 1x, and then minus, well, if I factor a 3 from 18, that's going to leave me with 6. And since I've already taken the x out, it's just 6 and not 6x. Okay, so now I have two factors, 3x times x minus 6 is equal to 0. So now let's set each of these factors equal to 0. 3x equals 0, and then x minus 6 also equals 0. Okay, so when I divide by 3, x is still equal to 0, and x is equal to 6 as well. So my my solutions to, or my roots, solutions to the quadratic equation, or where it crosses the x-axis, which are the x-intercepts, are 0 and 6. Okay, well, let's say I didn't see that I could factor out a 3. Everything would still work out the same if I only factored out x. I would end up with 3x minus 18, and then when I solved, I would still end up with x equals 6. So it doesn't matter if you see the other coefficient right away, but at least what you should be looking for is that you can factor out an x from all the terms, from both terms. Okay, so if you can't do that, then you probably can't use the GCF method. It's probably one of the other methods, which would be difference of squares or perfect squares or something else. But this method is very useful because it saves us lots of time. So I hope these videos have helped you, and now you can go ahead and continue with your practice. Thank you. And stay tuned for the next series.